Hello class, now let's discuss plane analytic geometry 2, which includes the topics general equation and standard equation of straight lines, parallel and perpendicular lines, as well as distance from point to a line. So now what are the general and standard equations of a line? So the general equation of a line is ax plus by plus c. The standard equations of a line have 5 different forms. First is the 2-point form. Second is the point-slope form. Third is the slope-intercept form. Fourth is the intercept form. And the fifth form is the normal form. For the 2-point form, the given are 2 points of the line, which are x1, x sub 1, y sub 1, and x sub 2, y sub 2. The formula to get the standard equation of a line using the 2-point form is y minus y sub 1 over x minus x sub 1 equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So in this formula, the values of x sub 1, y sub 1, x sub 2, and y sub 2 can be, you can get these values from the given 2 points. The next form is the point-slope form, in which the given are a point x sub 1, y sub 1, and the slope m of the line. So the formula for this form to get the standard equation of a line is y minus y sub 1 equal to m times x minus x sub 1. So the value of y sub 1, m, and x sub 1 can be, you can get this from the given. The third one is the slope-intercept form, in which the given are a y-intercept b and the slope m of the line. So the y-intercept b is it is from the point 0b. So the y-intercept can be located at the y-axis of the Cartesian plane. So you can see the figure here, the Cartesian plane, in which it has a line. So the point at which the line intersects the y-axis is the y-intercept. So it is the point 0b. Of course, the slope of this line is m. So to get the standard equation of a line, the formula for the slope-intercept form is y equal to mx plus b. The fourth one is the intercept form, in which the given values are the x-intercept a and the y-intercept b. So the x-intercept a is from the point a0, and the y-intercept b is from the point 0b. So the formula to get the standard equation using the intercept form is x over a plus y over b is equal to 1. The a and b values are from the given. The last form is the normal form. When you say normal, it means perpendicular. So the given values for this normal form is the distance p of a line from the origin, as well as the angle that this line makes with the positive x-axis. So to further illustrate these given values, let us have this Cartesian plane. Let us draw a line here. Okay. So the shortest distance of this line from the origin is its perpendicular distance or its normal distance. So the distance of this line, this perpendicular line here, is denoted as P, while the angle that this line makes with the positive x-axis is denoted as theta. So the formula to get the standard equation of a line using the normal form is x cosine theta plus y sine theta is equal to P. So we have here 5 different forms to get the standard equation of a line. So you can use one of these forms depending on the given. So if the given are 2 points, then you can use the 2-point form. If the given values are 1 point and the slope of the line, so you can use the point slope form, and etc. So let's proceed to the parallel or perpendicular lines and distance from a point to a line, as well as the distance between two parallel lines. So what is the condition for parallel lines? So let us have here line 1. So what is the condition for parallel lines? Let us have here 2 lines. The first one is line 1 with the equation a sub 1x plus b sub 1y plus c sub 1 is equal to 0. And we have here the second line, in which its equation is a sub 2x plus b sub 2y plus c sub 2 is equal to 0. So how will you say that these 2 lines here are parallel with each other? So you can say, or you can conclude, that these 2 lines are parallel if a sub 1 over b sub 1 is equal to a sub 2 over b sub 2. So if they are equal, then they are parallel lines. So let us have here an example. So for line 1, the equation is 2x minus 3y plus 3 is equal to 0. And for line 2, the equation is 4x minus 6y minus 11 is equal to 0. So for line 1, let us first write the values a1 and b1. So for line 1, a sub 1 is 2 and b sub 1 is negative 3. As you can notice, for b sub 1, we took the sign of 3, which is negative. So if the sign is positive, or if it is plus, so the value is positive. So if it is minus, so take the negative value. So for line 2, our a sub 2 is positive 4 and our b sub 2 is negative 6. So okay, so substituting these values to check if the lines are parallel, we have here 2 over 4 and negative 3 over negative 6. So this is equal to 1/2 or 0.5. So 0.5 is equal to 0.5, therefore the 2 given lines are parallel. Now, what is the condition for perpendicular lines? So let us have here same line. Okay. So how can you say that these 2 lines are perpendicular to each other? So these 2 lines are perpendicular if a sub 1 times a sub 2 plus b sub 1 times b sub 2 is equal to 0. So let us have an example. So for line 1, we have 2x minus 5y plus 3 is equal to 0. And for line 2, we have 10x plus 4y minus 9 is equal to 0. For line 1, our a sub 1 is 2 and our b sub 1 is, this is negative 5. For line 2, our a sub 2 is 10. So this is not 4, this is 10. And our b sub 2 is 4. So substituting these values to the condition for substituting these values, we have 2 times 10 plus negative 5 times 4. So this is 20 minus 20. So this is 0. Therefore, the two given lines are perpendicular. Next, let's proceed to the distance from a point to a line. The given are the general equation of the line, which is ax plus by plus c is equal to 0, and a point x sub 1 and y sub 1. The formula to get the distance from the point x sub 1, y sub 1 to the line ax plus by plus c equal to 0 is d is equal to positive or negative a times x1 plus b times y sub 1 plus c over positive or negative square root of a squared plus b squared. So take note that the sign in the numerator is positive if the point lies above the line, and the sign of the radical in the denominator is the same as the sign of b. Lastly, we have the distance between two parallel lines. So if the given is the general equation of two lines, so they have equal value of a, so equal values of b, but they have different c values. The formula is d is equal to absolute value of c1 minus c2 over square root of a squared plus b squared. For sample problem 1, find the distance between the lines 2x minus 3y plus 3 is equal to 0 and 4x minus 6y minus 11 is equal to 0. So usually if there are problems like this, the two given lines are parallel. But then let us check first if these are really parallel lines. So first, let us write the equations of the lines. So given for line 1, we have 2x minus 3y plus 3 is equal to 0. For line 2, we have 4x minus 6y minus 11 is equal to 0. So let's write the values of a, b, and c. So for line 1, a1 is, so a sub 1 is 2, b sub 1 is negative 3, and c sub 1 is 3. For line 2, a sub 2 is 4, b sub 2 is negative 6, and c sub 2 is negative 11. So substituting Substituting these values to check if they are parallel or not, we have a sub 1 over b sub 1 is equal to a sub 2 over b sub 2. So we have 2 over negative 3 equal to 4 over negative 6. So simplifying, this becomes negative 2/3 equal to negative 2/3. Since they are equal, therefore the given lines are parallel. Next, let's solve the distance between these two parallel lines using the formula So let's now solve the distance. Using the formula d is equal to the absolute value of c1 minus c2 over square root of a square plus b square. So before using this formula, we need to, the two lines must have same A and same B. So in order to do this, let us divide equation 2 by 2. Okay? So line 1 is 2x minus 3y plus 3 is equal to 0. So the line 2 must have a value of a of 2 and a value of b of negative 3. So in order to do this, let us divide equation 2 by positive 2. So equation 2 is 4x minus 6y minus 11 is equal to 0. So let us divide both sides of the equation by 2. So the result is 2x minus 3y minus 11 over 2 is equal to 0. Now our line 2 has equal A and B with that of line 1. So this is line 2. So this is line 2. They have the same A. This is the A. So same. Both positive 2. They have the same B, which is negative 3. And C1 is positive 3. C2 is negative 11 over 2. Again, remember, before you use this formula, first simplify the two equations such that they have the same values of A and B. So since we have already obtained the simplified equations, we can now substitute the values of A, B, C1, and C2 to the distance formula. Okay, so D is, C1 is positive 3 minus C2 is negative 11 over 2 over square root of, we have A is 2 plus B, which is negative 3. So this is absolute value. So this is equal to 3 plus 11 over 2 over square root of 4 plus 9 absolute value. So 3 plus 11 over 2 is 17 over 2. This is over square root of 13. So this becomes 17 over 2 square root of 13, absolute value, and over 2 square root of 13. This is 2.36 units. So the answer to this problem is D. D is equal to 2.36. Let's proceed to problem 2. What is the equation of a line that makes 120 degrees with the positive x-axis and passes through to -1? So what are the given values? The given values are, first is the angle that this line makes with the positive x-axis, which is theta, equivalent to 120 degrees, and a point in the line, which is 2, -1. Let's plot this point here. So this is 2, -1, and it is 120 degrees with respect to the positive x-axis. So where is the angle here? The angle here is this one, from the positive x-axis. So this is 120 degrees. So the question is, what is the equation of this line? First, let us determine the slope of this line. So solving for the slope m, we have m is equal to tangent theta, which is equal to tangent of 120 degrees. So in your calculator, tangent of 120 degrees is negative square root of 3. So now, since we have already solved for the slope, then we can use the point slope form in order to get the equation of the line. So using point slope form, to get the equation of the line, we have the slope m is equal to y minus y sub 1 over x minus x sub 1. So substituting, we have negative square root of 3 is equal to y minus y sub 1, which is -1, over x minus x sub 1, which is 2. So cross multiplying, we have negative square root of 3 times x so negative square root of 3 times the term x minus 2 is equal to y plus 1. So substituting negative square root of 3, we have negative square root of 3x plus 2 square root of 3 is equal to y plus 1. So transposing, transferring this side of the equation to the left side in order to get the standard form of the equation, we have negative square root of 3x minus y plus 2 square root of 3 plus 1. So this is not plus 1, this is minus 1. because we have transposed positive 1, so it became negative 1, is equal to 0. So this becomes, let's further simplify this by making the numerical coefficient of x positive, okay? So let's multiply this by negative square root of 3. So both sides of the equation. So we have 3x plus square root of 3y plus 2 times 3 plus square root of 3 is equal to 0. So this one here is not positive, this is negative. So 2 square root of 3 times negative square root of 3 is negative 2 times 3. Okay? So what's the value of this? What is the simplified form? We have 3x plus square root of 3y. So what is negative 6 plus square root of 3? So this is 3x plus 1.73y minus 4.27 is equal to 0. So the final answer is 3x plus 1.73y minus 4.27 is equal to 0. So for problem 3, determine the equation of the perpendicular bisector of the line segment joining 3, 4, and point -4, -1. For this problem, let us first determine the slope of the line segment joining the 2 points. After that, let's determine the midpoint. After that, let us determine the equation of the perpendicular bisector. Okay, so first, solving for the slope of the given line segment, we have m is equal to rise over run, or y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So what are the values of our x and y's? So for x sub 1, y sub 1, this is 3, 4. And for x sub 2, y sub 2, this is -4, -1. So substitute these values here. We have m is equal to -1 minus 4 over -4 minus 3. So this is -1 minus 4 over -4 minus 3. Or m is equal to, this is -5 over -7, or 5 over 7. Now, what is the slope of the perpendicular bisector? So, what is perpendicular bisector, by the way? So let's try to plot the given point so that I can illustrate to you what is perpendicular bisector. So plot point 34. So this is 3, 4. Next, plot negative 4, negative 1. So this is negative 4, negative 1. So let's join these two lines in order to get the line segment. So this is just a line segment. So from here to there. Okay. So the perpendicular bisector is the line which divides this line segment into two equal parts. Okay? So since it is perpendicular, therefore, it makes a 90-degree angle with the line segment. So let's try to draw. Let's try to draw this perpendicular bisector. So this one. So since it bisects, so it divides the line segment in blue color, it divides this line segment into two equal parts. Therefore, this is the midpoint of the 2 points here, and this line here, the green line, makes 90 degrees. So since it is perpendicular, so this is 90 degrees. Okay, so this is a line. Okay, so now let us determine this midpoint here. So solving for the midpoint, so the x coordinate is just the average of the two x coordinates. So this is negative 4 plus 3 over 2. So this is negative 1 over 2. So for the y coordinate of the center or the midpoint, we have negative 1 plus 4 over 2, or this is 3 halves. Therefore, the midpoint is at negative 1/2, 3 halves. So this point here is negative 1/2, 3 halves. Okay? Now, we're going to use again the point slope form. So our point here in this line is the midpoint, this one, and our slope will be the next value to be determined. So if the slope of this line segment here, if the slope of this line segment is 5 over 7, what will be the slope of the line which is perpendicular to this line segment? So the technique is that the slope of the perpendicular line is just the inverse of this, but the sign is negative. So the negative inverse. So therefore, this is negative 7 over 5. So this is the slope of the perpendicular bisector. Now, since we have already the values, slope, and the point, we can now get the equation of the perpendicular bisector by using the point-slope form. So, using point-slope form to get the equations, we have, so this is the form of the point-slope, y minus y sub 1 over x minus x sub 1. So our m, remember the m here is this one because this is the slope of the perpendicular bisector and not this one. So we use this here. So this is negative 7 over 5 equal to y minus, so what is y sub 1 and x sub 1? So this is the point in the perpendicular bisector, which is the midpoint. So here. Therefore, this is y minus 3 halves over x minus negative 1 half. So, simplifying, we have y minus 3 halves over x plus 1 half. So, cross-multiplying, we have negative 7 times x plus 1 half equal to 5 times y minus 3 halves. So, this is negative 7x minus 7 halves equal to 5y minus 15 over 2. So simplifying, let us multiply both sides of the equation by 2. So y2, so we multiplied both sides of the equation by 2 in order to eliminate the denominator 2. So this is negative 14x minus 7 equal to 10y minus 15. So simplifying, this becomes, let us write it here. This is 14x plus 10y minus 8 is equal to 0. So this is the equation of the perpendicular bisector. Okay. So let's proceed to problem 4. For problem 4, determine the distance between the line 3x minus y plus 5 is equal to 0 and the origin. So what are the coordinates of the origin? So the coordinates of the origin is just 0, 0. Okay? So let's write the given here. So the given are, first, the line 3x minus y plus 5 is equal to 0, and the point 0, 0. So this problem is very easy because you just have to substitute the given values to the formula. So what is the formula for this problem? The formula for this problem is D is equal to positive negative ax1 plus by1 plus C1 over positive or negative square root of A square plus B square. What are the values A, B, C? So this is C, not C1. And X sub 1 and Y sub 1. So our A here is just... So our A is coming from the line, equation of the line. So our A is positive 3. Our B is negative 1. And our C is 5. Now, what is our X sub 1? Our X sub 1 is 0. And our Y sub 1 is 0. So, substituting these values to the formula, we have D is equal to positive. So, let's try to omit this signs here. So, at the end of our solution, let us just take the absolute value of our answer, because that's it. So, when you are measuring a distance, just take the absolute value. So the signs are just indicators if indicators of the direction of the line. So let us just take the absolute value, the positive value of our answer. So our A is 3, our X sub 1 is 0, our B is negative 1, our Y sub 1 is 0, our C is 5, and this is over square root of 3 square plus negative 1 square. So our D is 5 over square root of 9 plus 1. Okay? This is 0. This is 0. So the remaining numerator is 5 over the square root of A square plus B square. So 3 square is 9. Negative 1 square is positive 1. So this is 5 over square root of 10. So multiply this by 5 square root of 10. Square root of 10 over square root of 10. So this is 5 square root of 10 over 10. Or square root of 10 over 2. So the answer is D is square root of 10 over 2. So let's proceed to problem 5. So for sample problem 5, we have find the equation of the line through negative 1, 3 and perpendicular to the line x minus 3y is equal to 4. So this problem is the same with problem 4. We have here a given line, and it says that find the equation of the line which is perpendicular to this line. So again, we will use point slope form. But first, let us determine the slope of our line. Okay? So for the given, we have a point in the line. So this is negative 1, 3. And a line perpendicular to the unknown line. So this is x minus 3y is equal to 4. Okay. So first, let us determine the slope of the line in which we are finding the equation. So the slope of this line is just the negative inverse of the given line, since it is perpendicular to this line. So solving for the slope of this line here, so just arrange the equation. So from x minus 3, 4 is equal to 4. So arrange this equation into the points, into the slope intercept form. So negative 3y is equal to negative x plus 4. So divide everything by negative 3. So this is y is equal to 1/3 x minus 4 over 3. So the slope of this line is just the numerical coefficient of x, which is 1/3. Okay? Therefore, the slope of our line, the line in which we are finding the equation, is just the negative inverse of this slope. Or, this is, our m is negative 3 over 1 or negative 3. Okay? Now we can determine the equation of the line because we have already known the slope and a point in the line. So use point slope form to solve for the equation of the line. Okay? So using point slope form, we have m is equal to y minus y sub 1 over x minus x sub 1. So our m is just negative 3. Again, don't be confused with the slope. So use the slope of the line, which is negative 3, not 1/3. So y minus 3, x minus negative 1. So where did we get 3 and negative 1? So it is from here. So this is negative 3 is equal to y minus 3 over x plus 1. Cross multiplying, we have negative 3 times x plus 1 is equal to y minus 3. So substitute negative 3, this becomes negative 3x minus 3 is equal to y minus 3. And transposing in order to get the standard equation, we have 3x plus y is equal to 0. So writing our answer, so the equation of the line through negative 1, 3 that is perpendicular to the line x minus 3y is equal to 4 is 3x plus y is equal to 0. So if you want to check your answer, just for double checking if you got the correct equation of the line or not, just substitute the given point if it satisfies the equation, and then you find the slope of the equation if it is negative 3 and it satisfies this, no? When you substitute it, then you got the correct equation. So first, let us try to substitute negative 1, 3. So this is optional. You don't need to show how you check your answer during your assignments or quizzes. So you just do it in your scratch papers, or you can also do it in your final output. So it's okay if you have checking or not. Okay? So for checking, we have 3 times negative 1 plus 3. Is this equal to 0? So this is negative 3 plus 3. Is this equal to 0? Yes, it is equal to 0. So this is the number 1 checking. For the number 2 checking, let us determine the slope. If it is really negative 3, so just rearrange this equation into the slope-intercept form. So when I say slope-intercept form, the left side of the equation is only the variable y, then transpose everything to the right side. So this is negative 3x. Okay? So the slope in this form is just the numerical coefficient of x, which is negative 3. Therefore, the slope is negative 3. Is the slope negative 3? Yes, it is negative 3. Since the equation satisfies these two, therefore, your answer is correct. So if you have further questions, you can contact me through Messenger in our group chat, or you can comment on Google Classroom. So good luck on your assignment, and I hope that this set of problems will explain or will help you in solving the problems in your assignment. Okay? Thank you.